All right, a transversal. A transversal, awesome name. I love it. I love transversal. But it's a simple idea. The idea is it's a line that intersects two or more lines. And for this class, it's basically I'm just looking at a line and two lines. So an example of a transversal would not be L, because L is not colliding with two lines here. Wouldn't be M. Our transversal we're looking at is T. So in this example, we're looking at transversal T. T is our transversal. We have two ways to do that. I've noticed we're getting really sloppy with notations. We can put a T on there, which means line T because it's lowercase, or we can put line T. Those are the only two ways to write line T. What I've been seeing is people will put the line notation above that. The only time we use the line notation is if I'm using two letters, if I'm using 2 points to form it. So you have two ways to correctly identify the transversal here, and that is simply writing a T or putting line T. There's no symbol that we put above it. That is our transversal. That is something connecting two lines. Now, why is this important to us? Well, maybe you don't care, but why is it important to the math world? Well, when you have a line connecting two lines, you create a bunch of different items. You, in fact, create 8 different angles. So if I look here, we have 8 individual angles that are created. We could have 1, 2, 3, 4, 5, 6, 7, 8. And those angles come in specific pairs, which we'll get to in a second. But before we get to what the pairs are, let's stick with our transversal drawing here because I got something else I got to put on here. When you have a transversal, you always have two lines. Between those two lines is known as the interior. So you have an interior between the two lines. So that distance between these two lines is known as the interior. So basically our interior is anything between those lines. Now, be careful here. The interior is between the lines, right? Now, if I turn this so it's straight up and down, our interior will still be between the lines. The between the lines is the interior, not the up and down fashion of this. It's the between the lines that gives us our interior. Well, if we have an interior, we probably have an exterior. And the exterior is going to be anything outside of between those lines. So we'll have an exterior up here, and we'll have an exterior down here. It's important to know those words interior and exterior because it's going to depend on what angles I'm particularly looking at. Because if you look at that whole list of angles that we're going to do now, you have to find a way to just know what I'm talking about if I say a specific term. You have to know what angles I'm looking at. That is what this chapter is dependent on, that you understand what all of these angles mean. So let's go ahead and start. The very first pair of angles we need to learn is called corresponding angles. You'll see me abbreviate corresponding angles a lot with just CA. CA will stand for my corresponding angles. Well, the definition isn't the greatest. It just says angles on the same side of the transversal and in the same position. Same position is that kind of tricky part. So same side of the transversal, that we should be able to figure out. So if I look at my transversal here, I have a same side would include 1, 4, 5, and 8. All those would be on the same side of the transversal. The other side of the transversal will contain 2, 3, 6, and 7. Does that make sense? We have sides of our transversal. Now remember, your transversal might be switched, where it could be underneath your transversal and on top of your transversal. Don't think of everything being this order. All right, but then this says angles on the same side. So I know what same side means, and in the same position. So what they mean by same position, so same side includes 1, 4, 5, and 8. Anyone want to take a guess? If I look at 1, Now this is tough because we haven't gone through it. But what would be another angle that's in that same positions? It would be 5. Perfect. We would have 1 and 5. They're on the same side, and they're both kind of on that top left portion here. So if I asked for a corresponding angle, I would say angle 1 and angle 5. Angle 1 and angle 5. Now be careful, this isn't a plus symbol. I'll keep saying that. That's my and symbol. That is a symbol for and. Someone want to take a shot at another pair of corresponding angles? Yeah, Caroline. You're going to say 2 and 6. I agree with 2 and 6. Because 2 and 6 are on the same side of the transversal. They're both on the right side. And they're in that same position. Top position, top position. Anyone want to name another pair of corresponding angles? We've got 2 people that get it. You guys use to steal all of them? Let's do it, Savannah. You're going to say 3 and 7. Let's check out 3 and 7. Are 3 and 7 on the same side of our transversal? Yep. Are they in the same position? Bottom, bottom? Yeah. Angle 3 and angle 7. Caroline, you want to grab the last one so you can get all 4 of them? 8 and 4 would work as well. I'm going to put it in the same order. I'm going to do the 4 and 8, but 8 and 4 orders. Leave it that way. Ooh, I forgot to put an angle on 6. Those are actually all of our corresponding angles. Bless you. Because I used all 8 of my angles up. So when you're looking for corresponding angles, same side of our transversal and same spot. Top, top, bottom, bottom, top, top, bottom, bottom. Those are different pairs. Now our next one is called alternate interior angles. Alternate interior angles, the first rule is they must be both on the interior. So it says interior angles, non-adjacent and on opposite sides of the transversal. So they can't be on the same side of the transversal, and they must be between the lines. So if I say interior, there's only 4 angles that are on the interior, and that's 4, 3, 5, and 6. So if I ask for alternate interior angles and you give me anything besides 4, 3, 5, and 6, you did something wrong. Because it has to be on the interior, and interior's between these 2 lines. Does someone want to take a shot at giving me a pair of alternate interior angles? Minus the 2 people that already gave me all the stuff, because I think you guys are getting it. I just want to see if anyone else is getting it. What would be a pair of alternate interior angles? Yeah. 4 and 5? I'm going to say 4 and 5. Aren't those on the same side? So those would be same side interior. Those would actually be down here. Because same side interior says interior angles that are on the same side of the triangle. Do you agree 4 and 5 are on the same side? Are they on the interior? Yes. So would that make sense that they'd be same side interior? So if I was naming 4 and 5, I'd probably put them right here. So we'll put those in the same side. Angle 4 and angle 5 would be same side. Yeah, Matthew. Maybe 6 and 4. So are 4 and 6 both on the interior? Are they between the lines? Are they on opposite sides of the transversal? So would 4 and 6 be alternate interior angles? That's exactly what I put. I would go ahead and go 4 and 6. Kennedy, does that make sense? Why these would be same side and these would be alternate? We got the interior thing down. Now, what's the other one that I do for alternate interior angles? You want to do that one? Yeah.
3 and 5.
3 and 5, perfect. Angle 3 and angle 5. Now, Kennedy already started us on the 4 and 5, same side interior. What would be another pair of same side interior? If 4 and 5 are same side interior, what else would we have? Yeah. We would go 3 and 6. They're on the same side of our transversal, and it's the in-between. So that'd be angle 3 and angle 6. All right, so we handled all the interior stuff, right? We have our alternate interior angles. We have our same side interior angles. Now we're, yeah. Yeah.
Could it be like 4 and 3?
It could not be 4 and 3. It could. That's a good point, because it doesn't really say that it can't be. So alternate interior angles are non-adjacent. Non-adjacent means they can't be right next to each other. In fact, those would be an example of, we're going to talk about the linear pair, the one that makes a straight line. So they'll have their own name, linear pair. Basically, all of these angles are joining up these two lines. It uses both of these lines. Notice how 3 and 4 don't use this line. So that's not going to be one of those key ones we're looking at. But great question. I should have brought that up, and I didn't. But you did. You knew. All right. My next one is alternate exterior angles. So alternate interior angles were like 4 and 6, 3 and 5, because they're on the inside. Exterior, the only thing we have to change is they both must be on the exterior now. What could be an example of alternate exterior angles? Could we get someone new to take a shot? Otherwise, I'll just randomly pick on someone. You guys all gave answers. Someone new. Yeah. Give it a shot. 1 and 3. 1 and 3 are actually going to be, I love the guess. Angle 1 and angle 3 are actually known as vertical angles. So you have the alternate part right. Because you realize, okay, 1 and 3 are opposite sides of our transversal, right? But the only difference is alternate exterior angles must both be on the exterior. So the exterior must be up here, the exterior is down here. So if I want an alternate exterior with 1, I'm going to pick 7. The opposite side, but both of them are on the exterior. So that'd be angle 1 and angle 7. Does that make sense? Why it's okay. What's the other one? Yeah, Chris. 2 and 8 is perfect. Angle 2 and angle 8 are perfect because we have 2 is way up here. Opposite side of the transversal on the other line would be 8. All right, same side interior was like 4 and 5. So now if I switch to the exterior, I must be talking about 1 and 8. So that'd be angle 1 and angle 8. And if my same side interior angles are 3 and 6, then my exterior ones must be 2 and what? 7 is correct. It'd be 2 and 7. So all of these require 2 lines because we jump from one line to the other. And if you think about alternate interior angles, they both use the lines. Corresponding angles use both lines. You're jumping from this pair of angles to this pair of angles. That is how we connect these 4 to these 4 with these words right here. Then I added 2 more. 2 more are review. That's why they're shaded in. Those 2 are not required to have a transversal. In fact, I'm going to draw a quick drawing here where we have maybe a line, maybe another line. Let's go ahead and do 1, 2, 3, 4. So I'm going to get rid of this 1 and 3 real quick. Okay, your vertical angles are the pairs of opposite angles made by 2 intersecting lines. So your example of vertical angles would be something like 1 and angle 4. The other pair of vertical angles would be 2 and 3. There are no other pairs. I just copied and pasted. I was going to use the other picture, but I like it like this better. Now remember, the pairs of opposite angles made by 2 intersecting lines are congruent. We have that vertical angle theorem, that if you are straight across, you are congruent. That's important for us to keep track of. Straight across means congruent. Linear pair are 2 adjacent angles that sum to 180. Examples of linear pairs include angle 1 and angle 2. Angle 2 and angle 4. Angle 4 and angle 3. And finally, angle 3 and angle 1. Basically, if you're going straight across, straight down, straight left, right, you are making a straight line that equals 180 degrees. So 2 and 4, they make this straight line. 1 and 2, they make this straight line. 1 and 3, they make this straight line. So every one of these pairs, if I added it up, would equal 180 degrees. So if I had a problem, we could say measure of angle 1 plus measure of angle 2 equals 180 degrees. So the key here is 180. The key here is congruent. So linear pairs, you think 180. For vertical angles, think congruent. Okay? Now we have a whole bunch of angle relationships. Our job is to name the type of angle relationship or write none. So I'll do the first one. 1 and 8. 1 and 8. They're on opposite sides of our transversal. Remember, our transversal is that one that connects the two. Yeah. Go. What do you got? Those would be alternate exterior angles. Because I have one on one side of the transversal. I have one on the other side of the transversal. Remember, if we're past the lines, we're on our exterior, which makes our interior here. So when I'm looking for my interior, I'm looking that left to right is now my interior. It's between the lines. So 1 and 8 are definitely on our exterior. So those must be alternate exterior angles. I'd like you to try the rest of those. Name what pair of angle I'm trying to get at. If they don't look like anything, put none. All right, if you didn't get them done, cool. You just know you need to work on this stuff, right? Then we go back and we practice this stuff. Because I'm telling you right now, it's key that you guys can just go up vertical angles, up corresponding angles, up alternate interior angles. Because like I said, the entire chapter is based upon this concept. The only thing I'm going to add to it on, I won't see you till what, Tuesday? Is I'm going to add parallel lines to it. That's it. The lines become parallel. That's the only new rule, which comes with some caveats. But anyway, so if I look at 2 and 3, first of all, it's always a good idea to locate your transversal so you know if things are on the same side. Your transversal this time is this one. It's going the opposite direction. That is our transversal. So if I look at 2 and 3, those are on the same side of the transversal because they're both above the transversal. They're also on the interior because, like I said, our interior for this one will be between the lines. That is your interior right here. So 2 and 3 are on the same side of the transversal. They're on the interior. The nice thing is our name is same side interior. So these will be same side interior. All right, 5 and 7. 5 and 7. Now, they're on the same side of the transversal, but one's on the exterior and one's on the interior. So it can't be something like same side interior. They can't be same side exterior because one's on the interior, one's on the exterior. So then we start looking at, wait, of these 4 angles, 5 is in the bottom left. 7 is also in the bottom left. That makes them corresponding angles. Those will be corresponding angles. And let's see if me maybe highlighting it for the couple people that got it wrong, or the few people that got it wrong, that's what corresponding angles look like. Bottom left, bottom left. Corresponding angles would also be 1 and 3, 2 and 4, 6 and 8. Okay, my next one is 1 and 6. 1 and 6, if you look at 1 and 6, 1 and 6 do not need this secondary line. To get from 1 to 6, I didn't need the 2 lines, which means it's 2 possibilities. Either it's a linear pair or it's a vertical angle. That's the only thing that can be if I'm down to just 4 angles. And if we look at 1 and 6, they're straight across from each other, which means they are vertical angles. It also means they are congruent. We have to know that vertical angles are congruent because we're going to get to things where I tell you that this is like 30 degrees And you have to go, oh, this one's also 30 degrees then. Okay, so those would be vertical angles, but I'm also thinking congruent. Vertical angles, and I'm thinking congruent as well, that they're equal to each other. All right, 2 and 7. 2 and 7, if you shaded in your interior, you'd realize that they're both on the interior. They're just on opposite sides of that transversal. One's on top of the transversal, one's on the bottom. That means they're alternate interior angles. Int angles. 2 and 6, once again, we don't need the other line to get from 2 to 6. 2 and 6 are one of these four. That makes them a linear pair. 2 and 6 form a straight line. They are a linear pair, which means you're going to think 180 degrees. Linear pair, and I'm thinking 180 degrees. 1 and 3, 1's top left, 3 is top left. That makes them corresponding angles. They're in the same quadrant, top left, corresponding angles. They're on the same side of our transversal. One's on the exterior, one's on the interior. That makes them corresponding angles. I'm going to put CA just to speed up my work here. So those should be corresponding angles. And our last one is 5 and 8. Well, 5 and 7 are corresponding because they're in the bottom left. 5 and 8 are both on the exterior, and they're both on the same side of our transversal. They're both below it. So that'd be same side exterior. Same side exterior angles. So sometimes I'll put the SS just to shorten, not writing same side every single time. We good with that? We got to be good with that with one transversal because it gets harder. Because sometimes you'll have multiple transversals. Yeah, that's what we're going to do next. But I'll show you an easy way to kind of deal with multiple transversals. When I give you a pair of angles, there's actually only one transversal you can look at. Everything else has to kind of disappear. So here's how we're going to kind of look at that. So it says we're supposed to name the transversal and what type of angle they are created. Notice we have a T. T is for naming our transversal. A transversal is a line. So we must be naming a line there. So the first one says 3 and 6. Now, here's my advice to you. Figure out what lines create angle 3. So I'm actually going to physically highlight these. And if you have colored pencils or regular pencil, do the same with me. We are talking about 3 and 6. To form angle 3, here is my angle 3. This is how angles work. They take two lines to make an angle. I use this and this to make angle 3. Now remember, see how I needed a portion of this line? That means I actually needed the entire line. So I'm going to dash it and say, okay, to make this angle, I actually needed this entire line. To make angle 6, I'm going to do that in maybe purple. To make angle 6, this is angle 6. So I put a dot there. I'm like, okay, what forms this? This right here. Which means I technically needed all of this line too. We can dash that as well. Did I highlight K at all? No, that means in your head K is gone. K is gone because I told you about the two angles that are important. That means K is gone. Now, do I have two lines and a line connecting those two lines? Did I highlight two lines and a line that connects those two lines? I hope so. Let's count them. I got a line, I got another line, and I have a line connecting them. The line connecting them is your transversal. So when I ask you to name the transversal we are using line J. So your transversal for this one is line J. And we're going to notice that the two things are between the two lines, so it's interior We're on opposite sides of our transversal. Which one has it? Interior, and we're on opposite sides of our transversal. What type of angles are those? What was that? I said, what type of angles are those? 3 and 6, based upon that picture? Alternate interior. They're on opposite sides of our transversal, and they're on the interior between those lines. So we'd have alternate interior angles. Yes. At the end of the day, the alternate interior angles is really the really important part. But to know that, you have to know what transversal you're looking at. Okay, my next one is 4 and 11. If I highlight 4 and 11, I'll maybe put a dot on both of those. And we'll figure out what lines make up those angles. So once again, just show yourself what makes up those angles. And let's go ahead and I'll use maybe orange to highlight the other angle. If done correctly, and if it actually works, you should see a clear transversal. Remember, you can just take your pencil and color them in. I have colored pencils too if you'd like to borrow them. But we should be able to see this line right here connects these two shaded in lines here. M does not matter to us. M does not matter to us. So our transversal must be one of these 3 lines, and our transversal is always the one that connects them. And that would be what, L? So that would be line L. And these would be same side interior angles. Why don't you take a second and try the next 2. We're going to try C and D. Yeah. Okay. Caroline? No, we're done saying sorry. Either we clean it up or we don't. No more sorries on that. Okay. 9 and 16. If I put dots in 9 and 16, I do encourage you to circle. Maybe you can erase it later if it's just one picture. But I do encourage you to note which ones we're talking about. We're talking about 16 and 9. I'm going to do this one a slightly different way than I did the other one. So the other ones I highlighted the angles. We could see our lines definitely, right? This time, all I'm going to do is I'm going to highlight the line that kind of connects the two. The line that goes from here all the way to 6. That must be this line here. Do you see how that line is the line that connects these two, kind of? Maybe it's a bad word because it doesn't go straight from it. But this is the only line that goes from 9 to 6. That must mean that is our transversal. That must be our transversal, so that should be line, this says link, line K. And we're going to notice that if this is my transversal, then these must be my 2 lines. And these are both on the exterior. They're on opposite sides. So this would be alternate exterior because we're opposite sides of our transversal. And we have alternate sides of our exterior. Yeah. So alternate exterior angles. All right, 10 and 14. Once again, I strongly encourage if you have the opportunity to circle those 2. I'm going to notice once again, the line that connects those 2 is K. You need K to get from 10 to 14. So that must be our transversal, is line K. And we're also going to notice this is bottom left, bottom left. Those must be corresponding angles. Okay, let's push on. If we look at the next part, it doesn't ask you to name the transversal, but you still need to know what the transversal is to know what kind of angles those are for your interior, exterior, and stuff. So if I look at 5 and 13, if you have like a pencil, you could like very lightly, because you're going to have to erase it because it's the same picture. But if I look at 5 and 13, what I'm doing in my head is I'm picturing, well, this is the line that connects them all. Although it doesn't ask it, B is my transversal. These are both on the same side of the transversal, but one's on the exterior, one's on the interior. That's top left, and so that should be a corresponding angle. Corresponding angle. I think, give me 1 second here. Where did I put that? Let's look at number H, or letter H. There's no number H, it's a letter H. Let's do H together real quick. H says 6 and 11. If I look at 6 and I look at 11, does anyone see one line that connects both of those together? Bless you. Can I follow one line and get to both 6 and 11? No. There is not one line that connects those two. These are not related. So for 6 and 11, we're going to write none. For 6 and 11, we're going to write none, because there is not a straight line that connects both of those. I'd have to go here and then here, which means there is no transversal that connects those. There must be one line that connects both of those angles. Real quick. So put a pin in this. We're going to finish this. We're going to need it checked off by me so we can get it correct. Part of your homework is this. This is kind of a one-stop shop for getting stuff done. If we're looking for a transversal of 1 and 12, well, 1 is here, 12 is here. All I'm looking for you to write here is just line L. That's all I'm asking for here, line L. For everything else, there's way more pairs in this. I just want you to name some of the corresponding angles you see. So for example, a corresponding angle for me, I might see how 1 is in the top left? 5 is also in the top left? I could name 1 and 5. So it's your job to name all of your angles, 1 and 5. Name 5 of those. Name 5 you think are alternate interior, alternate exterior, same side interior, same side exterior. And here, just name a couple that don't work. So I could see a couple that don't work. I'd pick 1 and 13. 1 and 13 don't work because there's not one line that connects 1 to 13. I do want to show one more thing, and that is homework number 7. If we look at homework number 7 together, I give you 2 angles just like we did, but I ask one additional question. So I said look at 7 and 11. So we look at 7 and 11, 7 and 11. Maybe I make my marks here. I figure out the line that connects those 2 angles. That's this red line right here. So my transversal is line M. But notice it asks a secondary question. It asks, what lines are there? So we're going to name our transversal and the 2 lines that the transversal intersects. So that transversal, that red one there, intersects this orange line here and this orange line here. Maybe orange was a terrible color because it's already orange. Let's go ahead and do purple. So I'm looking at this line and this line. And so the 2 lines I would name would be N and P. And if I was to name that angle pair, it would be same side interior. There is a chance that none might be your answer. There might not be a transversal. There might not be 2 lines. There might not be a specific pair. Questions on any of that? Okay, then what I would like you to do is I would like you to finish up this chart. I will post the answer in like 6 or 7 minutes. So you can just look up there and go, yep, 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 nope, nope, nope. Yeah. Oh, yeah, 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 yeah.